right, chemical bonding, and we're doing covalent bonding. So this is non-metal, non-metal. We're in the petroleum unit or organics chapter. So we're going to focus on non-metal, non-metal bonds. So when we have a bond, what is the maximum number of electrons that can occupy the first energy level? So, whoops, there we go. The answer there is 2, and then the next question says, what is the maximum number of electrons that can occupy the second energy level? We're going to say 8. And from there on out, we're going to say every shell can have the maximum of 8 when it's bonding. So every valence shell. Valence means as far out as possible. We call that the Octet Rule, where every atom, once it's bonded, needs to have 8 electrons. So on the second page, I'll show you how to apply the Octet Rule. So for now, we're just doing like Lewis structures. So you're going to fill out the table. 4 is done for you. I'm going to do hydrogen and oxygen for you, and then you can do the rest. Hydrogen is right here on the periodic table, so its symbol is H. Its atomic number is 1. The number of electrons, so everybody in group 1 has 1, group 2 has 2, group 13, 3, 4, 5, 6, 7, and then neon and down is 8, and then helium right here is 2. These guys all here, we consider that they have 2 as well. However, they can change, which is why their charges change from the ionic chapters we did last semester. Anyway, again, remember we're doing like non-metal, non-metals, so we're going to be operating like in this area anyway, and then hydrogen. So how many electrons in the outermost energy level? 1. And then to show the electron dot structure, we're just going to put that 1 valence electron. Okay, so moving on and doing oxygen. Oxygen is right here. So oxygen is O. The atomic number is 8. Number of valence electrons is 6. And then I'm going to go ahead and draw my oxygen. And then just as a reminder, when you're doing Lewis structures, there's sort of like this invisible box that sort of goes around your symbol. And every side of that box needs 1 electron before any side can get a second. So there's 4 electrons, but I have 6. Remember, 6 was my valence, so I need to add a 5 and a 6. You could really add them anywhere. I just picked there. So I'm going to go ahead and draw them in here. 1, 2, 3, 4, 5. There's my 6. So that's all you're doing. You're just doing individual atoms for this first page. You're not actually making compounds. On the second page is where you'll make the compounds. Since like methane CH4 is in your book, I'm going to skip that one, and I'm going to do carbon dioxide for you. You can look up that methane one if you want, or again, try it on your own. Let's see, I think I'm going to start with water, since water is a little easier. So electron dot formula is going to show me all the dots, and then structural formulas where you're going to be allowed to make bonds. So I have 1 oxygen, so I'm going to go ahead and draw my oxygen, and we just said we had 6 valence electrons. 1, 2, 3, 4, 5, 6. So there I drew my 6. Oxygen's right here, it has 6. Hydrogen is right here, and it has 1 valence electron. So I have a hydrogen with 1 valence electron. I have 2 hydrogens though, so I'm going to need to draw a second hydrogen with a valence electron. So now any electrons that are in pairs, we consider a lone pair. Those ones aren't going to bond. The ones that are by themselves are the ones that are going to make the bond. So here is a bonding electrons, and here are bonding electrons that are going to form bonds. So this is the electron dot formula. When I draw the structural formula, I'm going to put my oxygen here, and then I'm going to draw little lines to indicate the bond. So every line that you draw is 2 electrons. The octet rule I was talking about earlier is you should be able to count everything. So hydrogen will have 2 electrons, which this bond here counts as 2 electrons. So there's 2 electrons on the hydrogen, there's 2 electrons on this hydrogen, and then on my oxygen, I have 2 electrons here, so that's 2, 2 here, so that's 4, and then I have these 2, which is 6, and these 2, which is 8. So I do have 8 valence electrons, or 8 electrons around my oxygen, which is the octet rule, that you need 8. The only one that doesn't really apply to that octet rule is going to be hydrogen. Hydrogen needs 2. Everyone else is going to need 8. So I'm going to do carbon dioxide. Carbon dioxide actually has double bonds, which is why it gets a little harder. So that's why I figured I'd wait for that one. But I'll go ahead and do it now. So I'm going to start with carbon in the middle. The first one, like whatever you wrote here, the first one, unless it's hydrogen, it's not going to be in the middle. What I like to think about it is the one that has less. So here I have 1 and here I have 2. So the one with 1 is going to go in the middle. Here I have 1 and here I have 2. So this one's going to go in the middle. When you have 1 of each, there is no middle, right? It's just a straight line. Okay, so carbon is right here, which means it has 4 valence electrons. So I'm going to draw on the 4. And then I have oxygen, which we already said has 6. So I'm going to go ahead and draw on the 6 valence electrons here. And then I have a second oxygen, so I'm going to stick it over here where I have some space and draw on that 6. So now I'm going to go ahead and, again, I'm going to bond the ones that are by themselves. So those 2 are by themselves, those 2 are by themselves, these are by themselves, these are by themselves. So what wound up happening here is we created double bonds. All of those electrons had to bond. You cannot make a triangle. I can't make the oxygen bond to the oxygen. They have to go to the central atom. So when I draw it as a structural formula, I have the carbon. There's no lone pairs on the carbon, and I have a double bond to this oxygen. And then I have a double bond also to this oxygen. And that's it. So go ahead and continue the rest of the worksheet. Please let me know if you have any questions.